All right, let's consider the second question under Newton's second law of motion. But before we solve this question here, class, let's understand the question perfectly. They said a constant force of magnitude F acts on an object of 0.04 kg initially at rest at a point O. If the speed of an object when it has moved 50 meters from O is 500 meters per second, what is the value of F? So we are asked to find the force on this object, that is the value of the force. F is representing force, okay? But before we solve this here, let's list out the parameters. Let's take solution first. Let's write solution. The solution first, okay? Now, class, let's understand this question in a diagram here. Now, let's have this as the surface. They said a constant force of magnitude F acts on an object of mass 0.04 kg initially at rest. So this is where the object is resting. Let's just put this as a surface, smooth surface, okay? Now this is the object here. Please just permit me for the freehand sketch, okay? Now this is the object here. And the mass of this object is very small. The mass is 0.04 kg. This is mass. And this object is at rest. Now, there's a statement that you should consider. Whenever they say that an object is at rest or an object starts from rest, it means that initial velocity is equal to 0. Now, when they say an object comes to rest, it means that v is equal to 0. Please consider this. Whenever they say an object moves in a constant velocity or uniform velocity, it means that a is equal to 0. Now, this statement here has mathematical expression or values. So when they say an object starts from rest, that means u is equal to 0. An object comes to rest, that means v is equal to 0. An object moves with a constant or uniform velocity. That word constant and uniform is the same. Please take note. It means that a is equal to 0. Please take note of this. So now there is a force acting on this guy, on this object, and we are asked to calculate the force. Please take note. Now this object is starting from a point O. Now we label this point to be O. This to be O. Okay, I think it's not visible with this pen. We label here to be O. Okay, now let's say if the speed of an object when it has moved 50 meters, so from this O to this point now is 50 meters. Okay, from O is, so the velocity this object will move from O to the 50 is 500 meter per second. So this is diagram. This is the explanation of the. This is the explanation of the question. Okay, but please don't be afraid of this. So whenever you have a question like this in physics, the first thing to do is to list out the given parameters. Okay, now let's list out the given parameters. Now the given parameters here, the first one is mass, and the mass is 0.04 kg. The object is starting from rest, so this is 0 meter per second. The velocity is given to us as 500 meters per second, and the distance is 50 meters. Now we're asked to find force. Please take note. Okay, class. If you look into this question here, that's relating mass and force. Mass and force. Any question that relates mass and force, that question must be Newton's second law of motion. Please take note. Remember, what causes motion is force and mass. So let's write down the formulas related to Newton's second law of motion. So the first formula here is F is equal to m into v minus u over t. That's the first formula here. The second formula here is F is equal to ma, and the third formula here is for impulse, and we're not asked to find impulse, so it's either this or this. So let's see if the first formula is having the available parameters or is the second formula. Remember, we are asked to find force, so we're asked to find force, and force is in equation 1 or also equation 2. Force is in equation 1 and also in equation 2. Now mass is here in equation 1, also in equation 2. Class, if you look into this particular parameter here, we can use equation 1 and equation 2. Please take note, depending on, we can use equation 1 and equation 2. But in equation 1, what is our limitation here in equation 1 is t. While in equation 2, what is the limitation here is acceleration. Either t or acceleration can be calculated using equation of motion. Please take note. Either t or a will be calculated using equation of motion. And what are the equation of motion here? The first equation of motion is this, that the first equation of motion is this, that acceleration is equal to v minus u over t. Please take note. Now the second one is v squared is equal to u squared plus 2as. The third one is s is equal to ut plus half at squared. And the last one is s is equal to u plus v over 2 times t. So I will call this one here equation 1. This is my equation 2. This is my equation 3. This is my equation 4. Please take note. Now, depending on the one you want to use, either you want to use equation 1 or equation 2. Okay, when you want to use equation 1, the limitation to equation 1 is time. That means you have to look for time from this equation of motion. While if you want to use equation 2, the limitation here is acceleration. Please take note. So you have to find acceleration depending. Okay. Now let me use equation 1. Let me use equation 1. So our limitation here is time, that is t. So from this equation of motion here, either equation 1 or equation 2 or equation 3, equation 4, which of them here is having the available parameters? Okay, now if you use equation 1, acceleration is not given to us and time is not given to us, so two parameters are unknown to us here, so it's impossible. So if you use equation 2 here, acceleration is okay, we can easily find acceleration here and replace into equation 2. So since I'm using equation 1 here, that means my intention here is to find time. Please take note. If you're using equation 3 here, that means when you replace, time is not given to us and a is not given to us, so there's two unknown here. So if you use equation 4, this is given, u is given, v is given, so we can easily make t the subject of formula. So let's use equation 4 here to calculate for t and later replace t into this formula here. Are you okay with that? Okay, let's do that. Equation 4 to be s is equal to v plus u over 2 times t. So let's replace s. S is 50 is equal to 500 plus 0 over 2 times t. So we know that whenever you have any expression and there is bracket in that expression, first of all, simplify what is inside the bracket. When you do that, we have this to be 500 plus 0 will give us 500. So this will be 50 is equal to 500 over 2 times t. So 2 go here is 1, 2 go here is 250. Please take note. So I will have this to be 50 is equal to 250t. So making t the subject, our t will be equal to plus 50 divided by 250, and my answer will be 0.2 seconds. Okay. Now class, we have calculated for the t, so we can easily find the force. So remember the formula for force here is F is equal to m into v minus u over t. So replacing this, since we are asked to find force, remember we are not asked to find time in that question, we are asked to find force. So replacing the parameters here, I will have this to be mass is 0.04 from the equation into 500 minus 0 here over 0.2. So F will be equal to plus 0.04 times, let's simplify the bracket, that is, this will be 500 minus 0 will give us 500. Please take note. 500 over 0.2. So punch your calculator. 0.04 times 500 divide by 0.2. We have this to be 20. That is 0.04 times 500 is 20 over 0.2. So our total answer will be equal to plus 100 newtons. Okay, thank you. So for the next video, there is question 3 on Newton's second law of motion, where we have two forces and we are asked to find the magnitude of the force using Pythagoras theory and all, and we'll be asked to find acceleration. All you have to do is to hit the subscribe button to get question 3 on Newton's second law of motion. Thank you.